This is an analysis of horror movies. This project focuses on analyzing horror movies to uncover patterns and trends in the genre. The main tasks of the project are to find common characteristics in horror movies, predict if a movie is in a collection or series or not, predict the success of a movie in terms of its popularity, and categorize movies based on their similarity. This project utilizes two data sets. The first is specifically horror movies with over 32,000 instances and 21 features. The most relevant features are release date, popularity, votes, genres, original language, collection, and runtime. The second data set is the data of over 1 million movies sourced from the movie database online. There are many similar features here, but the added one of interest is the keywords. These data sets will be joined on both title and release date, essentially adding keywords to the first data set. For methodology, first there's preprocessing. Preprocessing consists of removing missing values where appropriate, creating features such as decade and a binary variable indicating if a movie is in a part of a collection, outlier detection using box plots, log transforms based off of histograms, data frame creation. For exploratory data analysis, numeric variables will be examined using summary statistics, histograms, and a correlation plot. Categorical and text data will be analyzed using frequency counts. This process will be repeated for standalone and collection movies to compare. To classify if a movie is in a collection or not, numeric-only data will be used, the scaled data in the case of SVM. There will be an 80-20 train test split, and grid search with cross-validation will optimize parameters. Models trained include KNN, decision trees, LDA, and SVM, and they will be evaluated based on train and test accuracy, F1 scores for both levels, and AUC. Regression models trained on numeric data with an 80-20 split will be used to predict popularity. Feature selection will identify the ideal percent of features to keep, and grid search will find the ideal alpha values for regularized models. RMSE will be the optimization metric. Models include OLS on the selected features, ridge regression, and lasso regression, and they will be evaluated based on RMSE, R squared, and MAE. Clustering will be performed on the scaled numeric data as well as keywords to compare the results. Elbow plots and silhouette scores will determine how many clusters. Both k-means and hierarchical agglomerative clustering will be performed, and clustering will be evaluated by silhouette score and interpretability. Summary statistics and frequency counts of each cluster will be compared in order to define them. Now for the results. Exploratory data analysis revealed a lot of variety in genres. Besides horror, there was thriller, comedy, science fiction, and even musicals found. The dataset had more modern movies. The most common keywords were usually either subgenres or common horror elements. There was little to no correlation between numeric variables, as seen in the plot below. Collections tended to favor the science fiction and action genres, while standalones were more likely to be mysteries or dramas. Standalone movies also tended to be less popular on average. For classification, all four models had similar performance, with 87% accuracy and a low F1 score for movies and collections. AUC was poor, with 0.59 for most models and 0.5 for SVM, as seen in the plots to the right. Models were much better at predicting standalone movies, likely due to class imbalance. SVM did not predict a single movie as being in a collection, the worst model by far. LDA had the best recall for collection, making it arguably the best model. Feature selection found that predicting popularity was best with only 45% of variables. The ideal alpha value was large for ridge and small for lasso regression, 10 and 0.006 respectively. All three models had similar performance with R-squared scores around 0.76, training RMSE of 0.514, test RMSE of 0.485, and MAE of 0.350. The higher R-squared and lower error metrics suggest that the models are a good fit for the data. Clustering for the numeric data generally resulted in groups being defined by decade. The k-means with 9 clusters had 2 groups representing the 2010s and 2 non-decade groups, while Hack with 6 clusters had a pre-1980s group. Clustering by keywords resulted in groups defined by horror subgenre, such as slasher, zombie, vampire, found footage, and alien. K-means with 8 clusters resulted in 2 groups with only 1 movie and 1 group with the majority of movies, and Hack with 0 clusters resulted in 1 group with over half of the movies. The silhouette scores were generally low, with the highest being only 0.21. The clusters had high intergroup similarity, below intergroup dissimilarity. In conclusion, horror seems to be a diverse film genre in terms of audience reaction, subject matter, genre, and language. Genre and audience response differ between movies in a series and standalone movies. The data shows to have potential to differentiate between collection and standalone movies as well as to predict popularity. Horror movies appear to be best categorized by either decade or genre, depending on the type of data. Grouping by decade suggests that there have been changing trends in horror over time, and grouping by subgenres shows that subgenres have associated tropes that are captured by keywords. These patterns and trends can aid in the discussion of horror as a genre and serve as a guide for the creation of more successful films.